Hello, welcome to today's webinar, Getting Payback from Generative AI. I'm Elizabeth Heichler, Editorial Director at MIT Sloan Management Review, and I'll be moderating the event today. Today's program is sponsored by SAS. So our webinar today addresses a significant challenge many business leaders are currently facing: how to realize tangible benefits from their investments in generative AI, specifically tools based on large language models. We're joined by Rama Ramakrishnan, whose practical framework for evaluating use cases provides a systematic way to determine where LLMs can provide return on investment. Rama is a professor of the practice here at the MIT Sloan School of Management, specializing in the practical application of predictive and generative AI techniques for industry problem solving and the development of intelligent products and services. He has over 2 decades of experience as a tech entrepreneur and executive, with a track record of founding and leading software companies that were eventually acquired by technology giants such as Oracle, Salesforce, and Demandware. Rama, welcome.
Thank you. Thank you very much, Elizabeth. It's great to be here. Hello, everyone. I'm delighted to have this opportunity to share some thoughts on how we can get value from the use of large language models. So my plan for this morning's presentation, before we start the Q&A, is really, I want to cover sort of 3 broad areas. We will start with a quick refresher on how large language models work. Much of this will be very familiar to you. And then I will speak about how businesses are adapting sort of off-the-shelf large language models for particular tasks or use cases that they might have. And there are really 3 foundational approaches that I will cover. And then we will sort of spend some time on the sort of key shortcomings that large language models exhibit. And then that feeds directly into what I sort of think of as the generative AI cost equation, which I've found to be quite useful in getting a sense for whether a task is a good candidate for us to try to build an LLM application around. So let's start with the first part, which is how large language models work. All right. Now, you might know that large language models are fundamentally deep neural network models that have been trained to predict the next word given sort of the first part of a sentence. And this has been done across billions of sentences. I did like a rough back-of-the-envelope calculation at one point. GPT-3 from OpenAI, which is sort of one of the first large language models to sort of burst onto the world stage, was trained on roughly 30 billion sentences pulled from the internet and from databases of books and so on and so forth. Now, initially, when these models are trained, they do a pretty poor job. So, for example, if you give it the cat sat on the, it might come back and say something ridiculous like spaceship. And then you sort of apply the mathematical equivalent of a rap on the knuckles, also known as stochastic gradient descent. And then if you do it repeatedly and train it for a long enough period, it gets remarkably accurate at predicting the next word. Once this happens, at the end of this training process, which might take millions of dollars and many weeks and so on, the large language models get really good at essentially autocomplete. Now you give it any phrase, such as, the cat sat on the, and you feed it into the large language model. Under the hood, it essentially calculates the stable that you see on the right. Now, we don't see the stable when we are working with a web interface, of course, like when we use ChatGPT or Claude or whatever. But this is basically what's happening under the hood. And folks who work with these models using the API will be very familiar with this. Now, what does the stable contain? It basically, you can think of the stable as having basically 2 columns. And the rows of the table correspond essentially to what's called a token, technically. But I will just use the word to refer to this because I think it gets at the conceptual heart of this thing. So imagine that the table has a row for every word in the dictionary, starting with aardvark, let's say, all the way to zebra. And then for every such word, the second column of this table has a number, a probability number between 0 and 1, which gives some rough indication of how likely is this word to appear after the input phrase that we fed it. So, for example, here it's saying that the word mat has a 20% chance of appearing after the phrase "the cat sat on the." That seems quite plausible to me. Maybe the word fridge has a 5% chance of showing up. The word aardvark has basically no chance of showing up, just not very plausible, and you get the idea. Now, once this table has been created by the LLM, we can either pick the most likely word, which in this case happens to be Matt, and then just output that, or we can essentially sample a word from this table. By sampling, I just mean that you sort of reach into this table and pull a word out randomly, and the word that you pull out, the words which have a higher probability are much more likely to be pulled out by you, right? That's really what I mean by sampling. So maybe most of the time you are going to output Matt, some percent of the time you're going to output fridge, and so on and so forth. And because of this sampling process, LLMs can actually generate different answers to the same exact question. Now, with this sort of basic capability of producing the next word, given an input phrase, we can imagine taking this, the first word that you produce. Now I'm just using the first sentence of the Gettysburg Address to demonstrate this. So I send in 4-7. Let's say the LLM produces something like years, and then I take years and essentially attach years or append years to the what I started with, send it back in, I get the next word, and I keep on doing this. And I keep on doing it till I hit some sort of a stopping condition. And by doing so, we can generate very, very long passages very easily. One important thing to realize here is that the LLM itself is only a next token or a next word prediction machine. The notion of taking that next word and then attaching it back and so on, it's not being done by the LLM. It's actually being done by a software that sits outside the LLM that's sort of orchestrating all these things. All right, now LLMs trained this manner are very, very good at autocomplete. So I have an example here of, someone says The Importance of Being on Twitter by Jerome K. Jerome, London, summer 1897, and the word it. And you give it this little prompt, and then it generates an amazing set of passages, which look like as if the writer Jerome K. Jerome actually wrote it, right? So they're very good at autocomplete, but they are actually quite bad at following user instructions. So I made this request to GPT-3 some time back. I said, help me write a short note, introduce myself to my neighbor. And then this is the response it came back with. What's a good introduction to a resume, and so on and so forth. Clearly, really doesn't make any sense. It does not answer my question. Now, the reason it does that, apart from unhelpful answers like the one we just saw, it can also produce offensive or factually incorrect output as well. The reason this happens is because, fundamentally, as we saw, the LLM was not explicitly trained to generate good answers to user instructions. It doesn't actually realize you're asking a question. It's simply trying to guess the next word repeatedly using what it has gleaned from all those billions of sentences. And so very often what happens is that in the training data, there are lots of lists of items. And when you have lists of items and when you are training the LLM on these lists, you give it a sentence, it actually thinks it's some element of a list, and it's trying to give you, plausible future elements of that same list. This is sort of one of the reasons why these things happen. So we need to essentially explicitly train it to follow instructions. And this approach is called instruction tuning. And OpenAI developed this approach. And the paper I have here is sort of the seminal paper that figured out how to do this. And instruction tuning made a huge difference. You send the same question as before to an instruction-tuned LLM, and you get an answer back, which looks like the kind of answers that we today get from ChatGPT and Claude and so on and so forth. Now, instruction tuning, followed by a step called reinforcement learning, led to the powerful frontier LLMs that we have all around us today. In the interest of time, I'm not going to get into how exactly these two steps work, but if you're curious, you can certainly see the short video I have on the Sloan website. Now, or you can read this explainer as well. So now let's switch gears and talk about how do we adapt an LLM for a particular use case. And as I mentioned earlier, there are three sort of basic approaches which can be mixed and matched for any particular task. First of all, I just want to point out that LLMs are really a platform technology. What that means is that using the LLM as a platform, we can build a wide range of applications on this technology. You can sort of think of the platform as being sort of this foundational layer, and then you can have all these applications on top of it. And very often, we can build applications incredibly fast using this technology. And broadly speaking, the way we adapt the LLM and build applications on the LLM platform, there are three broad approaches, which I will cover in turn. I also refer to these approaches as sort of adaptation strategies. how do you adapt an LLM? We'll start the simplest one first. And really, the starting point when you're considering a task in the business and you're trying to figure out, can I use an LLM here to automate the task in some fashion? I think a good starting question, in my opinion, is you have to ask yourself, can this task be done by a lay person using just common sense and everyday knowledge without requiring any sort of specialized training or specialized knowledge? If the answer is yes, then simply asking the LLM may actually be enough to get the job done. You may not have to collect data, train any models, and so on and so forth, like we used to do with traditional machine learning for many, many years. So an example of this, and this is called just prompting. That's the first strategy. And let's look at an example. Let's say if we want to build an application that takes in product reviews from an e-commerce site. You have a very healthy e-commerce business, let's assume, and you have people are crazy about your products, and people are leaving lots of reviews. And what you have discovered is that many of these reviews tend to be, oh, this is good, this is bad, but some reviews actually give you some insight into why they think something might be bad. In other words, a review might contain the germ of some insight about a potential product defect. And what you would like to do is to be able to automatically analyze all these reviews and identify only the ones that seem to have some insight into a product defect, so that you can take those few valuable reviews and then send it off to the merchandising team or the product team for further investigation and so on and so forth. Now, to do this back in the day with traditional machine learning, you'd probably have to collect, 5, 10, 20,000 reviews. Then you would have to manually label each one as either containing a defect or not. And then you would train a traditional machine learning model on this labeled data, and then you will deploy this model. But now, using LLMs, this actually becomes dramatically easier. So here I have a review of a chair that I just pulled from the Wayfair site, and the review says the curve of the back of the chair does not leave enough room for me to sit comfortably. So clearly, there is some potential defect about the back of the chair, which might be worth flagging for the product team. Now, the way you could actually extract this is by literally cutting and pasting the review into the prompt for an LLM like GPT-4 and simply asking the question, does the following review indicate a potential product defect? Answer yes or no. And when you do that, it comes back and says yes. And a lot of teams are finding that for these kinds of tasks, what I think of is sort of everyday text classification tasks, the LLMs actually are quite good. They tend to be really, really accurate. And so this is an example of how, for a task which a lay person can do by just reading the review without a ton of specialized domain knowledge, you can just get the job done using an LLM. Now, in many cases, this is not enough. We may need to provide the LLM with up-to-date facts about the world. As you folks know, large language models typically have like a training cutoff date. And beyond that date, they actually don't know what has happened in the world unless you actually feed that information to them. So that's one limitation. The other more important issue is that very often when you're building an application, you want the LLM-based application to leverage some proprietary knowledge that you have inside your enterprise. This could be proprietary data from a database. It could be company policy documents, strategy documents, things of that sort. And you want the LLM to leverage all this information to answer the question in the best way possible. A good example would be something like building a chatbot for a customer support use case, where a customer comes in with a particular question, maybe about whether they can return a product or something, and the customer support rep will typically sort of take that question, but may have to consult some product return policy documents and so on and so forth to be able to answer that question. And if you want an LLM to be able to do something similar, of course, it needs access to all these documents. So in these situations, what people do is a technique called retrieval augmented generation. And I want to say, first of all, this is just incredibly widely used. From what in my conversations with companies, this immediately comes up as something that they're trying. And the basic idea of retrieval augmented generation, often referred to as a RAG or AG, is very simple. Once the question comes in, you look at the question and you figure out what is the relevant content from all the things you might have. Maybe you have like 300 documents. You pull out only like the 3 documents that perhaps have some content that's germane to the question that's being asked. And then you take the question and the relevant documents or the relevant paragraph from these documents, and then you just send that into the LLM just as like a really long prompt, and that's all you need to do. And this technique can be very effective It's partly the reason why it's so effective and widely used is because the act of retrieving germane content from a corpus of documents, given a particular question, is a task that you can actually use traditional search engines for. Traditional enterprise search engines are really good for it. Information retrieval techniques are very good for it. And so you sort of piggyback on that knowledge and those investments if you already have done them. And so RAG tends to be a really nice bolt-on or add-on to those efforts. Now, so that is retrieval augmented generation, which is, to summarize, the prompt is basically a clear instruction or a question along with the relevant data that's been culled from a vast corpus of data. Now, I want to point out with these two techniques, the internals of the large language model are untouched. We are only changing the prompting. We are only changing the inputs. So since we are only changing the inputs, and we further know that a small change in the input prompt to an LLM can have a dramatically different answer. And the reason, by the way, why a single word can lead to a dramatic change in the output is because a single word change in the input sentence that we feed changes the probability table that we saw earlier, right? The probabilities of all the words will change dramatically as a result of this single change. And that's why everything will, there'll be a domino effect on everything that follows after that. So we may need to very carefully engineer the prompt to make sure that the answer we get is in fact the answer we want. And this goes with the name of prompt engineering, which is the art of designing the text prompt you feed in so you get the right thing back. And researchers have discovered various prompt engineering strategies. Perhaps the most famous one is this little sort of very humble-looking phrase called "let's think step by step." And it turns out adding this phrase to the prompt can actually improve the likelihood of a correct response, particularly if your questions are sort of reasoning-oriented, logic-oriented, arithmetic-oriented, and things like that. And just as a quick aside, this phrase, "let's think step by step," is actually called chain of thought. And as I mentioned earlier, it's perhaps the most famous prompting strategy. And the amazing thing is this idea, even though it sounds really simple, is in fact at the core of the more recent reasoning models that OpenAI has released recently, like O1 and O3, and that DeepSeek has become famous for recently with its R1 model as well. Now, let's actually see this in action. There's a very popular test of these LLMs called "What is the fifth word of the sentence?" And if you try it with GPT-4 or Claude, you will probably get the wrong answer. I've gotten the wrong answer, and I've tried it probably 20, 30 times. Here it says, what's the fifth word of the sentence? It says the fifth word of the sentence is the word "this," which is clearly wrong. The fifth word of the sentence is the word "word." What is the fifth word? Word. That's the right answer. So you get this wrong. And now let's add the magic phrase, right? And here I say, what's the fifth word of the sentence? Think step by step. And then it says the fifth word of the sentence is "this," which, note, it's wrong, as we saw earlier. And then it proceeds to do the step-by-step explanation. It identifies a sentence, it breaks up the sentence into individual words, it counts the words sequentially and correctly, and then finally it arrives at the right answer. So what I find amazing about this example is not just the fact that adding this phrase actually helps, but the fact that this phrase actually helps it recover from a mistake in the answer itself. So this is called chain of thought, and it's extremely commonly used. Now, I also want to point out that this sort of prompt engineering is not a silver bullet. There are no guarantees it's going to be working correctly all the time, but it does help. Now, we come to perhaps the most difficult situation where the task that we have in front of us cannot be done using common sense and everyday knowledge by a layperson. And often these tasks involve domain-specific jargon and knowledge, right? The standard examples would be things like, analyzing medical notes, legal documents, financial documents, basically any domain in which there is a lot of domain-specific jargon and knowledge. Those are quite hard for LLMs to just process just naturally off the shelf. Or you might have a situation where you know what you want in the answer, but you can't actually explicitly sort of describe it, right? A good situation here is, let's say that there is a law firm in which a senior associate is asking a junior associate to draw upon relevant case history and prepare a brief, right, or a response to a legal question. And if the junior associate comes back with the first draft, and the senior associate or the partner can then tell them, this is good, that's not good. They can give them feedback. So that's typically how these things work. So it's very difficult to sort of a priori describe in like perfect detail exactly how it should be. So we are very often in these situations when we're working with LLMs in these tasks. So in this situation, what you have to do is called instruction fine-tuning. It's actually very similar to the instruction fine-tuning that was done by OpenAI when they actually built ChatGPT. Now, of course, with instruction tuning, unlike the first two that we saw, the internals of the model will change. You're actually going to change the internal weights of the model. And the fundamental idea is that you take this LLM and then you train it further, much like the vendors did when they built it, and you train it with application-specific examples. So let's look at an example of this, right? And the key idea is that you create hundreds to thousands of high-quality questions and answers from your domain for that particular task. And a quick aside here, since this is obviously quite labor-intensive, it's often possible to use LLMs to actually help you create this data. This is called synthetic data generation. I just want to mention as a brief aside. But let's say you've created hundreds and thousands of questions. You take this, and then you can actually train an LLM with it. So here is a medical example where let's say that you're trying to build a medical chatbot for a medical diagnosis use case, and you have assembled hundreds of examples of this sort, right? Question and answer pairs. And here the question is, a 50-year-old male presents with, so on, et cetera, and you can read and you can see it's like a, it's the sort of question that might be posed to like a medical resident, for instance, right? A patient presents with a bunch of symptoms. What's the likely diagnosis? And then the answer comes back, and it's a very elaborate answer, and it's a medically sound and elaborate answer, right? As you can see here. So we collect lots of examples of this sort: question answer pairs. Then once we do that, we train the LLM. We give the LLM the question, and then we ask it to predict the answer. This is very similar to the, training the LLM as we saw earlier. We give it the cat sat on the and ask it to predict Matt. Elementary, my dear, ask it to predict Watson. It's the same exact kind of process, right? That's what we are doing here. But we are training it on your proprietary question answer examples. This is the key idea. And so and let me also point out that this can be quite labor intensive, because you have to collect the data, you have to train the LLM, and so on and so forth. You can't just simply try different prompting and make it work. So in general, what I find is that prompting is the easiest to do in terms of effort perspective, and followed by RAG and followed by instruction fine tuning. It's sort of like more effort and hopefully more payback when you do that. But this is not like you got to pick one and none of the other two. It's not mutually exclusive. Very often people will mix and match all these things. Okay, now I'm going to switch gears and talk about sort of the final part, which is based on these kinds of adaptation strategies, how do we go about identifying the right business use cases for a large language model? All right, now as we all have seen in our own personal experience, LLMs can do amazing things. But they can get simple things wrong, like we saw in this, what's the fifth word of the sentence example just a moment ago. Here is another one from maybe a couple of months ago, where you ask ChatGPT 9.11 and 9.9, which is bigger. It comes back and says 9.11 is bigger than 9.9. And apparently, the underlying reason is that the data on which the LLMs have been trained, there is a lot of data about software versioning and GitHub repositories and so on, where clearly from a software perspective, version 9.11 is more recent than 9.9. So the more recency has been sort of equated to bigger, and that's why the LLM is saying a 9.11. And so the LLM actually doesn't know you're referring to a number, in other words. And so what you want to do is you can go in there and say 9.11, 9.9, which number is bigger? That immediately sort of orients it the right way, and it'll get the right answer. But the point is, you can't be doing this sort of detailed investigation for every little thing it gets wrong. So you need to have a more general strategy. Now, the other problem they have is they often have difficulty with basic logic. This is a famous example, which is known in the industry, in the community as the reversal curse, which is you ask ChatGPT a question like, who's Tom Cruise's mother? It comes back with the right answer, which is Mary Lee Pfeiffer. So that information is, in fact, was in its training data, and therefore it's able to use it. Now, if you flip the question around and say, Mary Lee Pfeiffer has a famous son, who is he? It does not say Tom Cruise, it says it's Matthew McConaughey. And by the way, I double-checked, Matthew McConaughey was not born to Mary Lee Pfeiffer. And of course, as we all know, they hallucinate, they make stuff up. I asked it to list all the awards that I have won. It came up with a beautiful list of awards that I won. Sadly, I have not won any of these awards. It's simply not true. And then, so more generally, I think the output of the LLM can be problematic in many different ways. It can be inaccurate. It can be unhelpful, harmful. It can actually take your data and leak it to somebody else. It can take their data and leak it back to you in the answer it gives you. And then you end up using the answer in your business. You can actually get sued by the people who own rights to the data. And of course, if you're using a commercial LLM and you've built an elaborate application on it, and then they start changing the LLM on you, then the prompt that worked yesterday may break today, may not work today anymore. So you have to be careful. So there are a whole host of issues that you need to be worried about when you're using an LLM. Now, I want to point out that there is a massive amount of brain power, research brain power, being focused on these three problems. But the net of it, as of today at least, is that we don't have bulletproof solutions on this just yet. Now, on the data issues, some protections are beginning to emerge. You can actually opt out of having your data being used for training, right? All the LLM vendors have assurances to make sure that your data does not get used for training. You can opt out of it. And in terms of other data being leaked to you, protections are beginning to emerge as well. Microsoft and others have basically said that they're going to indemnify you if you use protected data and then get sued as a result of using that protected data. But given all this stuff, the big question, of course, is that how should we think about using LLMs for business productivity? You have a business process, which perhaps, basically it's a knowledge work-based business process. You have a lot of people doing it, and you're curious if you can use an LLM to perhaps automate some or part of it, part or all of it, and you're trying to figure out, like, how do I think about this? So what I find helpful is to essentially sort of take a three-step approach. Take the job you have, the process you have, the workflow you have, and you have to break it into discrete tasks. And for each task, you have to figure out if it actually makes sense from a cost-benefit perspective, and that's where the GenAI cost equation comes in. And then you basically, launch pilots and iterate and evaluate the pilots and see what happens. So the reason why we actually want to break these workflows or jobs into tasks is because typically a job is usually a collection of lots of very discrete tasks. And so, for instance, it turns out my job, being a professor at a business school, apparently has 25 tasks. A programmer's job has 17 tasks, and so on and so forth. And how do I know this? It's because actually there is an agency, a government agency, that tracks all these things. And that often is a good starting point for a particular job to figure out, okay, what is a good, collection of tasks that typically people have for this particular job. And then you can take it and then adapt it and change it to match the particulars of your particular business. Okay. So, and the reason why we go to all this trouble is that thinking of the job monolithically actually doesn't make any sense, because the task inside a job may vary a great deal in how automatable they are, how amenable they are to the use of an LLM. So for a business school professor, i.e. me, right, preparing lectures, evaluating and grading student work, preparing course materials and assignments, they are all partially automatable. And we, in fact, instructors, professors are already using this quite heavily, all over the world. Now, delivering the lecture, initiating classroom and moderating classroom discussions, obviously, we can't do that with an LLM all that easily, and mentoring new faculty and so on, right? So you get an idea. Some things are easy with an LLM, other things are really hard. And so that's why you go to the trouble of breaking jobs into individual discrete tasks. And now let's say that you have a list of tasks for a particular job. I think the next thing you have to ask yourself is, for a particular task that you're contemplating, does it satisfy what I think of as a GenAI cost equation? Now, the really important thing about using an LLM for automating something is that there are three really important costs that you have to worry about. Let's start with the most obvious cost, the cost of actually using the LLM, right? Using the GenAI tool. If you're using, for example, the OpenAI, one of the OpenAI models or the Anthropic models, and if you're using the API, you need to pay money to access the API, right? It's not super expensive, and we'll get to the cost in a second, but that's how we use it. That's the cost of using it. Now, but there are two really important costs, which I think are less obvious, even though they're, I think, much bigger than the cost of using. And that first cost is you have to adapt the tool for your particular task, in particular the degree of correctness for your task. And then you have to have some mechanism in place to detect and fix errors in the output of the LLM, right, when it attempts to do the task that you ask it to do. So let's look at these in turn. So for any particular task, I think the answer that you expect back from the LLM sort of falls on what I think of as sort of this correctness continuum or correctness spectrum. On the left, you have this these tasks where you can be pretty relaxed about the notion of correctness, while on the right, you've got to be really strict about what correctness actually means. So for instance, if you want to write a sales prospecting email or add copy for a marketing campaign, or an e-commerce product description, or any sort of creative output, like like a plot outline for a movie sketch. These are all questions which admit a whole range of correct answers. There is no unique right answer. And so this is sort of what I think of as on the relaxed end of the continuum. But there are other questions where you better get the answer right. What's the capital of France, right? Factual questions. What's the solution to this equation? Or something like, do I need to take a particular vaccine to enter a particular country, right? The list goes on. And these questions are much harder to get right because there's usually a single correct answer, and they require careful logical arithmetic reasoning, understanding of cause and effect, factual knowledge of the world, so on and so forth. And what I'm seeing is that a lot of high stakes use cases in business, medical, legal, financial, and so on and so forth, tend to be in this category. So if your task, if your use case happens to be on this end of the spectrum, right, you can actually go ahead and use the LLMs off the shelf, or maybe with minimal adaptation and not worry about it too much. But if you're on this end of the continuum, you have to really pay close attention to what's required to actually field an application successfully. First of all, you may have to adapt the LLM so that it actually complies to the higher degree of correctness that you have. Now, researchers have developed various methods. I talk about some of them in my SMR article, but there are many methods which are being developed to adapt the LLM. But they all have one thing in common. They require time and effort and money, right? So adapting doesn't come cheap. The stricter the correctness you want, the more expensive it's going to get. So that's the first thing. But the problem is none of these methods actually guarantee correctness at the end of the day, right? They will certainly improve the situation. Instead of having a high error rate, hopefully you'll have like a lower error rate. That's great, but there's no guarantee. And therefore, you need to have a really robust mechanism to check and fix the output of the LLM before it's seen by sort of the final consuming entity, the end user or whoever it is, right? And this robust mechanism typically is a human in the loop, right? There's a human in the loop. You're using that considerable domain knowledge to figure out if is there an error, how to find it, how to check it, how to fix it, and so on. Now that we have sense for these costs, we can actually set up the equation, and the idea is very simple. We estimate the cost of the genAI option, which is basically just, think of it as just like the sum of these costs, adapting, using, and error checking and fixing. And then we compare it to the cost of business as usual, the cost of doing it without genAI. And if this genAI cost, right, even in a ballpark sense, appears to be significantly lower than the other cost, that's a really good sign. And there's one more thing to consider, however, which is that despite your best efforts, things are going to slip through the cracks, right? Things are going to slip through. You're not going to catch everything. And so you have to ask yourself, if something slips through the cracks, can I absorb the cost of a miss, right? Liability, brand damage, reputational risk, and so on and so forth. And so that's the whole equation in full. So if both these conditions are satisfied, it's probably a good candidate for a pilot. Now, I want to point out that if this is done poorly, detecting and fixing errors, and if an application is rushed into production without this really being done properly, there will be high-profile blow-ups, right? Things are going to blow up, and there are all these examples that we have seen in the media of people rolling out chatbots without a human in the loop to check the output, and they're paying the price for it reputation-wise. Now, I'll point out that early rollouts are actually grappling with exactly these issues. There is a rollout of a system which can take doctors, physicians' sort of handwritten medical notes and go from the note to create a nice letter that can be emailed to the patient, sort of summarizing the visit. Turns out the system is obviously very useful, but the note that it's drafting, the letter that it's drafting based on the medical note, apparently, if the doctor doesn't edit it, if they just send it out to the patient without editing it, would have caused severe harm 7% of the time, right? So you have to be extremely careful. And these are all some of the tasks that I've seen satisfying the genAI cost equation: writing software, artistic work, written content generation, and so on and so forth. And I think writing software, as many of you know, incredibly widespread adoption of AI-based tools to make this super efficient. And the reason why it works so well is because if you look at the equation, well, the cost of adapting the LLM for code is zero because the LLMs have already been trained on lots of code, number one. Number two, the usage costs are dropping like a stone. The cost of detecting, fixing an error, there is no incremental cost because the whether it's human code or LLM written code, we have a process. It's called QA to test and debug and validate the software before we ship it. And then finally, software organizations know how to deal with bugs. Bugs are inevitable. We know how to patch. We know how to upgrade and so on. So we can absorb the cost of a miss. So that's why software development is heavily used to be able to, the LLMs are being heavily used to make these things really much more productive. Now, I want to say one final thing about the equation. If you apply the equation to a particular task and it turns out it doesn't pass it because these costs are too big, you should probably revisit it periodically, because as these LLM capabilities improve steadily, the cost of adaptation is actually decreasing quite a lot. So in other words, next month's frontier LLM version may actually be able to do the job with just prompting, even though this month's LLM requires fine-tuning, right? So that cost will drop. Now, the usage cost is actually dropping precipitously. And so GPT-4's API, for example, decreased 90% from March of 23 to August of last year. And this trend continues as we go. So you should probably revisit it periodically. And then the final step, of course, to run and evaluate pilots. And I strongly encourage an experimental pilot-oriented framework here. And there are 3 broad paths to pilot. You can actually use an application vendor. You can build your own application on top of a commercial LLM or an open source LLM. And of course, there's a gold rush going on, and everybody's building AI copilots for knowledge work and infusing it into every piece of enterprise software. All the big vendors are doing it. And this is just a snapshot of like the landscape provided by Matt Turk, and it's like mind-boggling the amount of activity in the startup space that's happening right now. And many of these startups are actually using third-party LLMs. They are using third-party LLMs. That's not the secret sauce. Their secret sauce is the way they have figured out how to adapt the LLM for the degree of correctness for that particular task, for that use case. And they've also created a nice UX and so on and so forth, which makes it easy for humans to catch errors and fix them so that it's not too burdensome. That's where the secret sauce, the edge is coming from for them. And of course, building custom applications is becoming very easy now with all the usual vendors. And then open source LLMs like Llama and Mistral or so on are really quite competitive, and they're great options to build these applications on. Now, I want to point out, however, that when building LLM-based applications, it's really important to have a rigorous evaluation process in place because it's much more difficult and tricky than evaluating predictive AI applications. If you're building, for example, an image classifier, which takes in the image of something and says, is it a dog or a cat, to use like a common example, the prediction is going to be only one of 2 things. Is it a dog or a cat? Which means you can check it against the right answer and say, yep, it's correct, or no, it's not correct. So you can automatically assess accuracy. But if you have an LLM-based, say, summarizer, which takes in a 10-page document and gives you a summary, 1-page summary, even if you have like a good summary to compare it with, how do you compare 2 summaries and say, yeah, they're actually the same? It's not very easy. How do you do it automatically? It's not obvious how you do it because there are an infinite number of variations here. And so typically people use something called an LLM as a judge and so on and so forth. And I cover some of these techniques in this other article in my recent column in SMR. So in closing, I just want to say that Rodney Brooks, who is a professor at MIT, has a wonderful quote that I have on the page here, which is that when you look at really successful AI deployments out there, typically they have a human in the loop somewhere, perhaps the end user, and the intelligence of that person smooths the edges, right? That's really important to remember. I think that's all I have. And good luck with your AI efforts. And I look forward to the questions. And Elizabeth, I would like to welcome you back.
Thank you so much, Rama. That was packed with a lot of information. So I suspect we're going to have a lot of questions from our audience just to ask you to elaborate on some of the things. But thank you. That's terrific. Just to get started, I do want to let the audience know again that if you do have a question, please put it into the Q&A model in the engagement panel. And I also just wanted to assure everybody that we will be sending out the presentation afterwards, as well as a link to the recording. So for first question, what is the most frequent mistake organizations are making when they're rolling out a GenAI-based solution that you're seeing in your interaction?
What I'm seeing in my conversations with companies, I think by far, perhaps the most common mistake is to take an LLM-based application and essentially rush it into production without having a really robust mechanism for checking and fixing errors. I think that's the most common one. And I have some sympathy for why this happens, because typically to have a robust mechanism, you need a human in the loop or humans in the loop. And humans in the loop is expensive. And it certainly gets in the way of a really nice, economies of scale argument from the use of this technology. So, and there are many sort of plausible reasons why this happens, but that absolutely is the biggest mistake I see. And I want to say that there is perhaps another mistake which is equally important, which I see in the development of the LLM itself, in the development of the application itself, where I think teams typically, they find this technology exciting, which is, I find it exciting too. I get it. But I think they don't spend enough time having a very rigorous evaluation process as they build the LLM-based application. As I mentioned in my presentation briefly, it's very tricky to evaluate how good these things are, unlike traditional software, unlike even traditional AI applications. And so having a good evaluation process is very important. And people typically have, at the extreme, they have what's called a vibes-based process, where they just send a few questions in, see if the vibe of the answer feels pretty good. And then if it feels pretty good, they just hit deploy and go for it. So I think these are all very human frailties. I have sympathy for that, but those are extremely common.
Okay. And one of our questions is, do you think that the open source GenAI models are opening a realistic opportunity for smaller or mid-sized companies to build their own trained models?
I think they are. I think the key, I would say maybe the key starting point when you're looking at this situation, if you're a smaller business, is that you should think of using LLMs for very narrow use cases, right? So because the narrower the use case, the smaller the LLM that you can get away with, right? And we have a plethora of open source LLMs of varying sizes, tiny, small, medium, and so on. So, and smaller LLMs are easier to train, they're easier to maintain, they are cheaper to run, they are faster to run, they come with a whole host of benefits. And I think that if you set your sights appropriately, or to put it differently, you don't want to have Socrates answering your RFPs. You don't need this amazing frontier LLM to answer a very narrow question. So what you do, for example, if you're trying to build an RFP answering LLM application, create a nice set of data examples of RFP questions and answers, and then use that information to fine-tune a nice open source LLM that you can get your hands on, and have a good evaluation process. And that probably is a really good starting point. Okay. So that's what I would recommend.
Okay, thank you. And just related to that, I'm wondering about current availability of talents and skill set on this. Are you getting any sense in your conversations with companies whether their own AI, sort of data science crews are embracing this and developing the skills that they need to work with this? Or are you more likely to be looking at hiring in the talent?
I think what I'm seeing is that yes, but I wish it could be better. And so I think particularly companies which actually have an existing data science group, and clearly the data science folks are sort of enlarging their toolkit to be able to work with LLMs and so on and so forth. And so they're in a good spot. But companies which may not have had a robust data science group or a centralized data science group, maybe they have data science talent scattered throughout their functional divisions. I think what they're finding is that very often they need to. There are pockets of talent in the enterprise, but the people who have this curiosity about LLMs, who have tinkered with LLMs and have built an understanding of these things, their titles may not reflect it. Because what you find is that there are many engineers, software engineers, who don't have a background in data science, who are actually very good at this stuff. But similarly, there are lots of engineers who are not that interested in this for some reason. Right? So it's not like every engineer is able to do this, even though they could if they wanted to. And then you find a lot of people, for example, there are business analysts, marketing analysts, data analysts, and so on, who have embraced this technology heavily. They're using it in their work. And of course, as even if they're banned from using this in their work, they're probably heavily using it at home. So the short answer is that there is a lot of talent. There is this dark matter of talent hiding in the enterprise. But so you need to actually go find those people. and get them and energize them and motivate them to do these things. And of course, you need to start hiring from the outside as well.
Right.
And the further thing I want to say is that, particularly for prompting, if you're using a frontier LLM, you can get a lot of things done just with prompting.
Mhm.
And to do prompting and prompt engineering, you don't need to have an incredibly strong technical background.
Yeah.
And very often I've had companies tell me that they have people with social sciences, liberal arts degrees, the so-called poets, who are actually able to be really good prompt engineers, even more than the quants sometimes. So the talent exists, it's scattered everywhere. It may not have the names you think it has. And yes, you need to probably hire up from the outside as well.
Right. Okay. Now I have a very interesting question here. The evaluation that you outlined was it oriented towards the question of using LLMs to achieve operational efficiency and finding payback there. What about the use of LLMs for innovation, such as developing new products, services? How do you evaluate the costs and benefits there?
That's a really wonderful question, and I should have been, I guess, clearer about the framing of my presentation. So it's focused on productivity, business productivity, and I sort of think of it as like the first wave of LLM adoption, right? And that's what companies are doing. They're looking at their existing processes. Typically, they're looking at processes where there's a lot of knowledge work that's being done. Filling out forms, for example, right? And then they're saying, okay, can I do it with fewer people? Or since the demand for this is increasing steadily, can I keep the team intact and be able to service the growth in demand without adding more headcount, right? That's sort of the frame that I'm coming in. And because that frame is very amenable to this level of, granular analysis.
Yeah.
Now, there's a vast set of processes, which, as the questioner posed, R&D, innovation, and so on and so forth. I think there, I find that people are using LLMs as a brainstorming assistant or a brainstorming partner, and they're not really thinking about evaluations and so on.
Right.
And I think it's kind of interesting because if you are working in R&D and if you have an idea for something, you probably, regardless of where the idea came from, whether it came from you, your colleague, or an LLM, the point is you need to do something about it. You need to actually, just like software, you write software, whether you write it or the LLM writes it, it has to be QA'd and tested. So similarly, in R&D, you will have to put it to the test and do things with it. So in that sense, you have sort of an automatic evaluation mechanism for any idea that people come up with right now in an R&D environment. And so you have to test it, and people are using LLMs as a brainstorming partner. So I feel like maybe given the primacy of needing to test ideas in these spaces, maybe having a super granular evaluation framework is not necessary at the moment. But as it gets more widespread, my guess is that we will start to use frameworks, because what's going to happen is there's going to be a lot of false positives. People are going to generate like a gazillion ideas very quickly with an LLM, and then you obviously can't be evaluating every one of them. So you need a framework to filter and prioritize and rank them. And I think that's where the energy is going to focus.
Right. Okay. And then can you also explain a little bit more about the additional layer in the recently introduced LLMs with reasoning capability?
Yeah, that's a very fascinating topic. And, if you recall this, what I call the chain of thought prompting strategy, which is the simple idea of saying, okay, let's think step by step. Now, if you look at the DeepSeek models, the recent R1 model, the OpenAI O3, O1 reasoning models, they all fundamentally have this idea. And this idea is that typically, when we train an LLM, we give it questions and answers. We give it the question and ask it to predict the answer, and we do it repeatedly till it gets really good at predicting the answer, right? That's the fundamental idea. Here, what we do is that we tell the LLM, I want you to first reason through how to solve this problem and then produce the answer, but I want you to produce both. If I give you a question, I want you to tell me what the reasoning is, and then I want you to tell me what the final answer is. And now I'm going to evaluate the answer based on whether it's correct or not, right? And of course, you can only do that for certain domains in which it's easily checkable, right? Math and coding, for instance. And which, in fact, that's why these models are really good at math and coding. And if you check it, and if the answer is correct, you do this thing called reinforcement learning, where you basically say, the kind of reasoning you did is really good, so do more of it. And if the answer is wrong, you tell it, hey, the kind of reasoning you did is actually not good, so do less of it. And if you do that, millions of examples, millions of times, it starts to get really good at reasoning, right? So that's the fundamental idea. And in some sense, it's very simple because it's the same idea. Give something, ask it to predict the output, and see if it matches what you wanted to predict, and if so, reward it. If it doesn't do, penalize it. It's the same idea. But here the focus is on not just predicting the answer, but the way you thought your way to the answer. So I think of it as a professor, the student gives me an answer to a question. I want to see the work. And if the work is correct and if the answer is correct, I'll say, okay, good, do more of this. If not, do less of it. That's sort of the fundamental idea.
Right. Okay. Now, I've got a couple of questions that I don't think these are necessarily easy to answer, but I think it's a topic that's on people's mind, which is kind of setting some expectations for length of payback. I'll put them both together for you. One of our viewers asks, usually the ROI in emerging technologies isn't captured in the first few years. So do we have a sense of an industry benchmark for LLM investments? And then relatedly, and someone else asked, when we look at the GenAI business case, what is a good payback or break-even period? Because it can be a long journey to develop an application based on specific data needs and deployment.
Yeah. So as you pointed out at the outset, these are tough questions. So I don't know if there is like an industry benchmark for the level of investment. So I just don't know. I haven't seen it. It may exist. I just haven't seen it myself. And I don't have any great insight into that. But in terms of the payback period, I think that's a very interesting question. So for instance, there's this company that I spoke to. They built an LLM-based application. And I won't, for confidentiality reasons, I won't tell you exactly what the application was. But basically, their use case involved essentially a lot of extraction of data, structured data from unstructured sources, and then use it to fill certain forms and things like that. And they were actually able to show that they could handle 30% more volume with the same team, right? And now this is just one data point. So for them, the payback was like literally in the order of months to be able to get this up and running, do the pilot, and see if it's any good. And if it's good, they're going forward with it. It all happened in a several month period. So I think the way to think about it, if I were actually doing it, I would actually look for tasks in which it's such an obvious fit to an LLM that I can literally, in a matter of weeks, field the first version of the application.
Yeah.
So it's almost like change the target so that it's easy to hit it. And I think by doing so, you will have like a pretty quick payback, or you will learn very quickly that it's the wrong target, right? Yeah. And I think more importantly, the act of trying to build these applications with these LLMs makes you and the team and everybody else collectively way smarter very quickly. And arguably, that actually is the biggest benefit of all.
Right.
Because I think what happens very often when I talk to CEOs and executives is that there is a sense of, okay, we need to do something because everybody is doing it. On the other hand, we don't want things to blow up and bad things to happen. So there is a sense of like hurry up and wait, right? And I think the way to get past that kind of dichotomous sort of paralytic sort of state is to say, we're going to do low stakes, easy things first.
Right.
And we're going to see what happens. But we're going to do lots of them very quickly. Right. And I think that is sort of the right model. And that kind of very scrappy, startupish, skunkworks-like model, as you know, is not very amenable to a lot of quantification when you're doing it. But I do think it's really important to do that. And I think a lot of companies are doing it, and they're learning really very quickly how these things work. And they're also attracting interesting talent from other parts of the company who all want to be part of that effort. And that's a great way to sort of attract people who actually really know this stuff and are spending a lot of time with it, even though they might be in disparate departments and so on and so forth.
Okay. And then we have another grouping of questions that I think that the subtext of this is angst from smaller companies. That is there a relationship between company size and ROI on GenAI, or do you have any examples or use cases of smaller, medium-sized businesses using AI with humans in the loop for real gains?
I think the biggest example I've seen with the SMB sector is marketing. Right. So, previously you might actually have perhaps outsourced a bit of your marketing campaigns, email campaigns, things like that, to a marketing agency. And now they're finding that there is a lot of it, they can just do it themselves. Right. Coming up with a nice subject line for an email, you don't need an expert anymore. You can just ask the LLM do it for you. You can give it the last 5 subject lines that worked really well, and it can give you 5 more like that. And so I think that, or broadly speaking, the generation of written content in low stakes use cases, right? That's how I would characterize it. I think I see SMBs doing it a lot. They're actually doing it themselves. They're doing it, using some of these bespoke tools that are available that are actually quite cheap. And of course, if they're using one of the CRM vendors, for example, the CRM vendors all have now like some sort of AI co-pilot thing for an additional fee. So I think that's where I see the most development. I would say, for example, just step back for a second, the biggest penetration of this stuff is software development, number one. Number two, followed by the generation of written content.
Got it. And we have time for just one more question. So let's talk about agentic AI.
Okay.
Which is really, how do you see LLM-based agents evolving to add value for business?
Yeah, that's a really good question. I think maybe let me just step back for a second and then maybe just place agentic stuff in a slightly bigger context.
Okay.
So I think there are 3 things that are happening in 2025, which I think it's worth paying attention to. One of them is that the LLMs are all becoming multimodal. They can handle not just text, but they can handle text and images and videos and so on, all in one shot. That's very important. Number 2, they're becoming agentic. And by that, and of course, you talk to 10 people, you'll get 11 definitions of what an agent is. So let me just very simply say, if an LLM has access to external tools, like a search engine or a travel site, or it is able to write programs and execute them, right? It has been trained to do what's called tool calling, to call tools at the right time. And it can further, if it can break down complicated tasks into smaller tasks and execute them one after the other, I think of it as like an agentic system. And then the third thing that's happening this year is these reasoning models, right? Like DeepSeek and so on and so forth that we talked about earlier. I think the really important thing that's going on is that these 3 things are very synergistic with each other. As you get better at reasoning, you get really better at taking a complicated task and breaking it into smaller parts that are logically consistent with each other, right? So reasoning makes a better agent. Similarly, the multimodality makes the agent more powerful because it can now browse websites, take screenshots of images on the website, figure out what the image is telling you, automatically enter your name into some airline booking engine and things like that. So these 3 things together are like the key thing to watch for. And so from that perspective, it's better to think of these 3 as a bundle and say what's happening to this bundle this year. And my feeling is that I think we're going to see much more of it. But I think there is this like there's an inconvenient question that nobody's answering, which is that if an agent has, let's say, a task, it needs to do 10 things one after the other. If it makes a subtle mistake in step number 4, who's going to catch it? Right? And again, so like what I've heard, funnily enough in the media, in social media, is that it's like, do not use an agent to order DoorDash. It's going to go to some other address, right? So that's sort of a fun example, but I think it's about keeping those kinds of things in mind. So I think if you can, agentic systems in which you can actually monitor what's going on and then interject at just the right moment to fix any errors that are happening, have a future, right? Because they are sort of this, human LLM hybrid. Again, going back to there's a human in the loop. There's a human smoothing the edges, right? So I think that's what we need to watch for. And there are some tasks which are very amenable to this sort of human in the loop insertion. And those tasks, I think, will benefit from agentic systems.
Right. Okay. Wonderful. Well, thank you so much, Rama, for sharing your interest. We have a lot more questions that I'm afraid we can't get to, and we will share those with our speaker. Again, thank you for your time, audience. Thank you all for being here. Thank you for your great questions. And of course, a big thank you to our sponsor today, SAS, for making this webinar possible. And so I'll just say thank you all for joining us today, and have a great rest of your day.
Bye-bye.
Bye.